Hey, what's going on, guys? We're back with the next part of our Learning C# tutorial, and today we're going to try and implement our distance system. Before we go ahead and do that, I'm going to revise some code here. Remember, like I said, I keep going back to this, how we should have created a system where the character and damageable systems were integrated. If it proves to be a problem later on, we're going to go ahead and actually implement that, but for now we're just going to revise this a bit. We're going to remove our distance from camera from our character script, because for now all he does is return animation and alert dead info, stuff like that. And we're going to move him instead into the iDamageable class. Okay? Now, actually, let me open that back up again. Set it equal to, we'll do 100. So the default distance away is 100 meters. Now what I want to do is down in here we'll do a separate manager similar to our shoot manager, but not quite, and we're going to call this distance check manager. Okay, and what we're going to do is we're going to copy this code here. Okay, so what this will do is we're going to get all the and actually I'm going to actually remove this wind here, because we don't want that when we're calculating distance. So it'll be the actual middle of the overlay and not with the wind. It's whatever we're checking on the middle of the screen. We're getting all those hits, and then what we're gonna do is for every hit there, we're going to check if it has an iDamageable, and then here, instead of doing the d.doDamage, we'll do well, okay, so before we go ahead and do that, up here, we're going to make a few new properties. We'll do a private float calculating distance time, set it equal to 0. Next, we're going to do a private float distance from target, and then we'll stick with those, and we might have to add another one. So we'll go ahead and do calculated distance time plus equals time dot delta time. And what we'll do actually is we're going to well, I'll explain why this it'll work for us. What I'm saying, there's a certain instance where this won't work, but I'll talk about it in a minute. And then in here we'll do else calculating distance time equals 0. And then in our info GUI here, we'll do if calculating distance time is greater than 3, show distance. We'll do else if calculating distance time is greater than 0, show calculating, and then otherwise don't print anything. Okay, so what this is saying is we have this calculated distance time, and we're saying while we're holding the mouse over the character, it'll add time that we've spent on the character, and once we're over 0, which is once we've actually started to calculate it, we'll print a thing to the screen saying calculating distance, and then once we've held it for over 3 seconds, then we're going to actually show the distance away where we can make the adjustment. So that just adds a little skill level to our game. Now, before we actually implement this GUI system here, what I want to do is we need to get or assign this distance from target. So what we'll do is distance from target is equal to d dot distance from camera. Simple as that. Now before I do this, I'm going to talk to you guys a little bit about something here. Let's say this is, it's not going to happen for us, but this is just a concept that you might want to think about, as we're calling this for every raycast hit this frame. So let's say we have two characters that are perfectly lined up. Now, because this is running every frame, it'll add 2 times the time per calculating distance, and you'll calculate it twice as fast. And the distance from target will be, it'll choose one of them. It'll choose the last iteration. It won't update for both of them. So it'll choose one of their distances, and then do that. So the only thing really that you'd have to worry about, let's say we have a mission where you have 2 guys and they're walking, and you have to line up a shot where it gets both of them at the same time. The only thing there is that while they're both aligned, your calculating distance will be twice as fast. However, I doubt it'll be a split second while they cross paths, so it won't even be a big deal. Just something to keep in mind. Okay. Next thing I want to do is I'm going to cut this, and this will be something separate. I'll explain in a minute. So we'll show the distance here. The rectangle I want is, we'll make a new one. We'll do rectangle R is equal to, I don't think we can call it R. Yeah, we have to call it something else. We'll call it rectangle R2 is equal to a new rectangle. And we'll do screen dot width divided by 2 plus 100. Screen dot height minus 200. And then we'll make it 200 comma 200. Okay, so we'll do a GUI dot label and we'll do int cast of our distance from target dot toString, and what we're actually going to have to do is this. I don't think we've talked about that before, so I'll talk about it in a minute. And then R2. Okay, so first thing is, what is this int casting thing that I was mentioning? What this is saying is basically we take our distance from target, which is a float value, and we're going to convert it to an integer. And what this will do is it'll just basically remove the decimals and convert it to a full a whole number. However, the reason this is red is because I just put them in the wrong order. The rectangle goes first, and then the string. Okay? And then in here, we'll just do the same thing. But instead of showing the distance from target, we're just going to print calculating distance from target. Or rather, we'll just do calculating distance. Because we only have, if you remember, 200 pixels, so I hope that's enough. It should be. And then down here we need to do our aim height correction. So we'll do GUI layout dot space 10. GUI layout. This will be at the top left, if you remember, because that's where we left off for our GUI layout dot label. And we'll do height adjust value plus height adjust dot toString. In fact, we're going to do if calculating distance time is greater than 3. So actually, I'm going to just move this into here just to save us some space. And then obviously we'll have to move our space above that as well. Okay. Now Sorry about that. I only got 10 minutes. Now, before we continue, we need to make this height adjust value, and that's basically the height we need because we're converting distance to pixels, and because let's say 100 is our default value, that'll be centered on. However, 100, the system will think that's 100 units you need to go up, and it's not. So we need to also adjust it for the power. So what we'll do is we'll make another private float, call it height adjust, and we'll do and here we'll do height adjust equals distance from target times, and we'll do 100 or current weapon dot power divided by 100f. So that just takes our 100 ratio again, multiplies it by our distance from the target, and that is the actual distance from the target. So let's say our guy is 100 units away, then it'll multiply that by our power. Let's say our power is 100%. It'll multiply it by 1, and then it'll just say the distance from target is 100. Other way around, if we say our power is 0, we do 0 divided by 100, which is still 0, multiply that by our distance from target, and it's 0. So actually, I need to flip it like we did that other time. So we'll do 100 minus this. This way, you know, things work out the way they should be. So, okay, it's not quite perfect. I'll explain in a minute, but this video is getting kind of long, so I'm going to go ahead and cut the video here and continue in the next one.